here we are, streaming again, right? I mean, it's what we do every once in a while. So we'll be working on more inventory stuff today. No plan on what's getting actually done. But we'll take each function and slowly churn them out over time. Okay. Oh. Hey, how's it going? Sure, where I'm going to start with this yet. I do need to open Discord inventory hell channel so I can figure out what I need to work on first. It's somewhere in here. Is it an Alfie? Inventory hell. Okay. Alright, so last time I worked on this, we had update data, we did find, we have some extra imports which we don't need. We don't have anything in here, we do have something in here. What's in here? This is the factory. So most of this is already here, but we don't have a way to do weight and stuff like that until we are done with some other things. So let's work on the actual inventory functionality and some of the stuff that needs to go into this. So let's take the... I'm going to take the shared as a base. Yeah, I'm going to take shared as a base. And then we're going to pull it apart. Mostly because a lot of this we actually do not need. But what we do need... Let's get rid of that. Let's get rid of this. I just need like one function or something to start with. Okay, invoke effect, we don't need that. We want something a little more complicated so that we have some base stuff to work with. Okay, so... Oh, we are going to need the state manager, so we'll keep that in there. Alright, so we're going to take the first thing, which is we need to do add. And we need to take an item and add it to the player. And I think it's supposed to... There's a stack option. We have to determine where it's going to get the item from, so I think we can just do... Yeah, we could just do item. And then we wanted an optional boolean, which is going to be stack. And then we're going to get rid of, I want to say, a majority of the stuff that's in here. So if player data inventory, we're going to do player data inventory. What's this? We want to do a type of check equals undefined. And then we define it that way. And then the rest of this stuff, we are going to make a copy of the array. Just going to be done like this, and then we do inventory. Good morning, friend. I recently increased my hard drive capacity, so I'm going to install Vermintide 2 soon. I would 100% be down to play that. So that would be awesome. Noel, how's it going? How's it going? I haven't played Vermintide 2 in a minute. Usually me and my wife play, so. But yeah, no, that sounds like a lot of fun. Vermintide 2 is a fantastic game. Okay, so we're doing inventory. We're going to be adding here, and we're going to do inventory with the key of type. Inventory key. Is this inventory? Yeah, this is inventory. Those are all the overrides. Let's just get rid of that for now. Inventory. Inventory. Okay, so we have our base set up for this. I got Vermintide 1 for Xbox for free and tried it, loved it. The online multiplayer's dead. Yeah. You can definitely find people playing more actively on 2. Plus we have, what is it? The new one that's coming out pretty soon. Next couple months? I'm trying to remember the name of it. I can't remember what the new one's called. It's... Yeah, I can't remember. But yeah, we'll definitely play some games. It'll be quite fun. Okay. So we're doing the add function for the inventory, and the way that it is described is kind of interesting. So let me just put that right here so we can actually see what the heck I'm working on. So this is what I described it as. It adds an item. It has a stack boolean to stack. Fail early if the inventory is full or no similar items. Auto stacks, auto recalculates weight, auto syncs, auto saves, auto returns remaining. So this is going to be a pain in the ass to write. I already know it is, and this function is going to be gigantic. But I don't know how we're going to tackle this yet. It should be the number remaining if it did not stack. So let's think about what we need to do to get this to actually function. So one of the first things that we need to do is check. We need to check if it's just being stacked. Let me think about this. So if we're trying to stack an item, we need to determine if there is anything else inside of this character's inventory that currently matches the base item that was passed from here. So what we should do is check to find any item that meets the criteria of it doesn't reach, or it's not the maximum stack. So from the item factory perspective, I actually think we're going to need to make this a promise. Maybe? Wait, let me check. So we want to check if the base item exists in the first place, which is important. So let's start with that. Okay, so let's do a few basic checks first. Check if the base item exists in the database. And we're going to do... Do we actually want to check this? Hold on. Because we also have like dynamic items that can be created. Like we're talking like t-shirts and stuff like that. I mean, I guess there could be a base item for it, but it doesn't really do anything. Do we check if it's a... Yeah, I think we probably should. Yeah, let's actually just check it. Alright. Does base exist? And then we do await item factory, get by name, or just get. Yeah. And then we just pass item.base. And then if does base item exist, we return item.quantity. It does make me wonder if we should really... No, we should definitely return like the quantity of what was not able to be stacked, if that makes sense. Okay, so once that is added there, we do base item check. We want to get the base item, which is going to be, I think, like get by name or something. Get. Do I not have a get by name? In a minute. Yeah, apparently I just don't have that. All right. Async function, get by name. Let's do string promise, and it's going to be a base item. Is it a base item? Yeah, base item. And we'll just do this, name to lowercase. This is technically the same function, but the only difference is it's just like a true, it's not true or false. Return base items index. Get base, get by name. All right, so we have get by name. So we could actually just do get by name, and then it's going to return undefined if it's not there. Actually, this should be. We want, hold on. And I also imported the wrong function. This should actually be item factory. Why is it importing item factory from... I don't want that item factory. I want this other item factory, which is, I think it's just called factory. Oh no, we have to import it a different way. Okay, so it should just be... Or is it inventory factory? I don't even remember what the fuck it's called now. What is this called? No, it is called item factory. Okay, I just need to fix the import. So item factory get by name. Let me see if it'll... Oh no, item factory. I'm having a brain fart here. Okay, we don't want from / item. We want import item factory from factory. There. All right, so we have item factory get by name, and then we're going to pass item.base, and then it's going to, we'll do base item like this, and then we'll do type of base item equals undefined. Then we return item.quantity. All right, so once we have the base item, we need to figure out what indexes can be stacked upon, if there are any. Actually, what we should really do first is, like, the stack part is going to be the hardest part. So what we really need to do is determine if there is an available slot for the item to be added. Now, the thing is, we don't have anywhere we don't have a configuration anywhere that says what the maximum slot count is for an inventory. So what needs to be done here is we need to define that, and it needs to be changeable, I believe. So we could do max slot count, and we can make this so that, like, it can be passed in. But here we're just going to define that 27, which is technically 28, is going to be the maximum amount. Because if, like, you think of an array, you know, 0 counts as a number, so this is actually technically 28. So we have 28 slots available. And with 28 slots, that means that, like, if we are doing a do not stack, so we are not stacking. Not stacking, just add it to the player's inventory. So this makes it easier for me to figure out what the what slots are currently available, if that makes sense. We do need to add a function for it. So what we can do is do a shared function, which is going to be like find available slot or get available slot number or something. So let's do that. So the logic behind the find available slot is we need a player. We need their inventory type. And then we need a type, which is going to be an item slot. And then it's going to return a number. Or, wait, it's going to return number or undefined. Or we just make one function that just finds any available slots or all available slots, which I think would also be appropriate. No, let's just do one. Let's just do one. It makes it simple. Let's not make it too overly complicated. So if we take the one slot that we need to find, which is we need to go into each inventory type and pretty much determine if there's anything in it. So if this type has nothing in it, we can just assume that the first slot is open. Which we can just return 0 here. But if we do need to do a max slot count, which is going to be a number. So that'll let us increment upwards or add additional to the array without even like trying. Find available slot. Okay, so let's loop through. So what we want to do is we want to do a for loop. So that means we're going to increment through each number of max slot count and go through each one of them. So if it's less than the maximum slot count, we're going to increase. We do want to do less than or equal here, though, because we're looking for like numbers like 27, I believe. So that should allow us to hit that 27 mark. Still increment one more, I believe. Okay. So we're going to loop through each one. We're going to go into the player's inventory, and we're going to find an existing slot for that number. So that means, does slot exist? And then we do player data type, find index, and we're going to check the item slot item dot. Ooh, that's interesting. We need to hold on. We need to convert this so that I can actually work with it. Let's do this. Put that in there like that. Then we do clear data items. Items. Find index. Item dot slot equals the number that we're looking for. If item index greater than or equal to 0, that means that the item was found. Means the slot is already taken. And what we want to do instead is return I if we do find it. Now, if we don't find anything in this loop, that means that all the available slots are currently taken. So that means we return undefined. So this is really badly written, so I will change this myself. Look into the inventory type, find or loop through all index values of max slot count and determine if that slot is already taken. If it is not taken, return the slot number that is currently available. There we go. And then we can just do returns number or undefined. And then up here we can just say returns undefined if no slots are available. Use a type of check to compare. All right, so now that we have that, we can now do, if we're not stacking, let's just do that for now. So if the items, hold on, let me think about this. Okay, so if we're not stacking it, we want to do two things. We want to do a, we want this add function to somehow be recursive, which is going to be quite tricky. But we also want it to handle not stacking, I guess. So we don't want to trust the player or the developer here to be like, hey, this is the correct stack amount that I want to add. What we want to do is we actually want to take the base item and compare the two. So we want like leftover after or remaining from max stack. So we want to do base item dot stack. Or wait a minute, we want to do. Let me think about it. Math.absolute. We want to compare. I believe we want to compare the current base item stack minus. So usually the stack is supposedly like the largest item or amount we can get, and then we want to remove what amount. Or no, we want to add from the item. Hold on, I'm really fucking having a brain fart here. So we're trying to add the item quantity, right? So let's say, okay, so let's just write it out. Let's say the stack size is 64. If the quantity passed from the developer is 128, that means that we take the stack size and subtract the item quantity. What is remaining is the amount left to continue stacking into another item. I think that makes sense. All right. Okay, so if we do remaining like that, so now we have remaining to stack. And what we want to do is we want to take the item quantity minus, or minus equals the remaining to stack. But it's only if it's if remaining to stack is greater than or equal to 1. All right, so now we know how much is left over that we need to continue stacking onto the next, this next recursive function. But first we need to add the inventory, or we need to add the first item to the inventory, or basically we just need to add the item to the inventory. One thing that I think is important here is that we make an item reference. So let's go ahead and do that actually pretty early. So we'll do item ref and we'll do a deep clone. And it should just be item or whatever. And we pass the item up here. Item ref. All right, so now we have item ref. And let's put that over here like this. All right, so we have our first item. It's going through. It's subtracting the quantity it wants to, or it's subtracting. Hold on, let me think. Remaining 2 stack. The remaining 2 stack math absolute. I'm thinking about what happens when the stack size is less than. Joseph, how's it going? So I'm thinking about the stack size, how it's like new to programming. Which language are you using right now? We are using TypeScript. But what I'm wondering right now is that if we... So this should actually only happen... Let's set this to 0. And then if base item dot stack is less than the item ref dot quantity, then we want to run these functions and change the remaining 2 stack value. Now we add the item at this point because we're now checking if the stack size is smaller than the current stack, but we are also checking if it's larger, and then we're doing the math to get rid of, or to start a recursive function, which is going to call this same function again and then add the item again because it's being stacked in the same way. Okay, I think it makes sense. Now I need to do the add-on part. So we need to get a slot that is currently available. So let's do that. So if we do slot and we do I'm sorry, we do, there's a shared function, but it is called shared dot find available slot. Shared dot find available slot. All right. And we need to import that specific one like this. Shared. Okay. Find available slot. So in order to find the available slot, we need to pass the player. We need to pass what slot we are looking for. This one's going to be inventory. And the maximum count, which is going to be max slot count, which is going to be inherited from above. And then if type of slot is undefined, we are going to return the full remaining amount. We should actually do this really early on and way ahead of everything else, because this is one of the criteria for stacking, is that we need to make sure that we have room. So here we're just going to return item ref dot quantity. So we're going to return the full amount because it never actually got stacked. That being said, that'll also handle recursive too. Okay, so now we add the item. Because now we have a slot, we have a amount that we want to stack, and we can go from there. So let's add it to the inventory. So we do items, push. We're going to push the item ref. And then what we're going to do is state manager. Actually, we don't want to... No, we do want to update the state. Yeah, so we want to use await state manager set player inventory, and then we want to pass items. And I think that's... Yeah, that's it. All right, so once this is set like this, and we update the state, we move on to do the next recursive function if it needs to be recursed. So that means if we do, if the remaining 2 stack is greater than or equal to 1, we are going to take the base item, the item ref, we're going to make another clone. New item ref. Then we're going to take new item ref, and we're going to set the quantity to the remaining 2 stack. And then we're going to do return. Can I just call this function again? Hold on. Yeah. All right, and then we're just going to add the same thing. So we're going to do player new item ref, true, and we just pass max slot account. So that'll keep recursing until we end up with 0 left. And it'll also return the remaining amount if we run out of inventory spaces. Yeah. So that will allow a recursive stacking. Recursive stacking is what this is. So recursively stacked items until no more room left, or item stack equals 0. Or adds items, rather. Because we're not finding an existing one, if that makes sense. Alright, so same thing with this one. So this time we're actually stacking, handle stacking recursively. Right? So in order to make this one happen, we need to think about a few things. Tinko, how's it going? So we have like... what we need to do is try and find a item that matches the base item, and then check its max stack size against the base item's max stack size. So there's some general criteria there, which means we need to see if we can find it. So let's do item index, and we're going to do items, find index, item dot, we're gonna actually open this up because we're gonna have to do quite a few comparisons. So if item dot what am I missing here? We're missing some things. Player data inventory. We need to convert that actually to the correct version, which is a array of item store items. So that should actually be here. This. And we need to fix some things. And then down here, okay, so now we do item dot slot equals, no, not slot. Item dot base equals base item base. So if it's not equals, return false. Now we need to check if item quantity equals base item dot stack. We also return false, because that means that we are it's already above max stack size. Check if item is missing, is not fully stacked. Check if the base item matches. And then we return true here. So now we have an item index, potentially. So the first thing that we're going to do is if item index is less than or equal to -1. This means that the item does not currently exist in the inventory with an incomplete stack size. The item does not currently exist in the inventory with an incomplete stack size. Yep, I think that makes sense. All right. Move that, sorry. Okay, so if we have an item index of -1, that means that what we are going to do here is we are going to find an available slot. And then if we don't find that available slot, that means that inventory is full. We can't stack it any further. Return the item quantity amount. That being said, now what we want to do is we want to do something very similar to what's up here. It's actually very, very similar. It's almost exactly the same, except, you know, I can't really recursively call that. So what we want to do here is we want to find the available slot, which is like this. We do remaining to stack. So if base item dot stack is less than item reference quality, we do remaining to stack item ref dot quantity. And then we push it into the array, we do the item reference. Okay, and then what we do here is we do the set state, we do remaining to stack is greater than equal to 1. We call the function again recursively, and then we do, this should actually be false here. But this one up here should be true. And then we pass the max stack size. Yeah, okay. And then this will just keep stacking it. Until we end up with no remaining amount, or if all the inventory slots are currently taken. Otherwise, we do item. This would just be 0 at this point, because we've pretty much stacked everything, and if we ran out of room, then we ran out of room. So that should be fine there. So it's similar functionality to this. But my question is, can I make that any better? Because we do have duplicate code here, and I'm wondering if I could somehow figure out how to recursively do this without having duplicate code. Because the logic is similar, right? Can we do that? Actually, no, I think we can. No, we 100% can. So what we can do instead is actually just do... Like, at this point, we know that no item like this currently exists. So we actually don't need to do this twice. What we do need to do is just call add, but then set stack to false. Because we know exactly what needs to be done here. And then we just return. Okay, yeah, so we just recursively just stack items, or not stack, but add items until we run out of room. Which means that it's going to be trying to fulfill the max item size. Okay, so now we have that part done, and then we can do the stacking logic here. So the stacking logic, so handle stacking logic here, we found a item that does not have max stack count. All right, so we need to determine how much needs to be added. How much to add. And we want to do base... No. Yes, we do math absolute, just in case, because I don't want to fuck that up. But we do base item dot stack minus items, item index dot quantity. So this is how much is left to add to it. And then what we also need to do, let's turn that into a const, is modify, we do items, item index dot quantity plus equals how much to add. So we add the amount that's missing to make the stack full. And once the stack is full, we need to take the remaining amount from the original item. Amount remaining in stack. So we do item ref quantity minus how much to add. And I think, do we need to do this here? No. Okay, so once we do that, if amount remaining in stack is greater than or equal to 1, actually this should be amount remaining to stack. and we do item ref quantity equals amount remaining to stack. And then we want to call this again recursively, and we want to stack it like that. And then otherwise, we return 0. So what ends up happening is that this will recursively call itself until all of the stack size is appended to the inventory. So the logic is, let's say you have a burger in your inventory, you have like 1 burger, right? And the max stack size is 64, and you want to add 128 burgers. So you go through, and the first check is going to be like, hey, I'm going to try and stack everything. So that's what this Boolean is. We're going to try and stack everything. And it's going to go through here, and it's going to be like, hey, this stack size is false. So we're not trying to stack here. We're actually trying to stack to already existing items first. So let's go through and check if that item exists. So that's going to try and find an item index for an item that already exists in like the array. So it's going to go into the inventory, and it's going to find that item index. If it does not find that item index, though, and says, hey, we did not find an existing burger here, we're going to go in here, and we're going to try to find an available slot. If an available slot for that new item does not exist, that means that the inventory is full, and we can return the remaining amount that did not get added to the inventory. But if the slot is available, what we do is we try to add that item again. But this time, we're setting stack to false. So that means we're adding new items to the inventory now. So it calls that same function again. And it's like, hey, this time we're going false. And then it goes in and it's like, stack is set to false. And now it's going to be like, okay, we're going to try and find that open slot again just to make sure, it's really there. And then once we find that open slot, we're going to take the total maximum size of the base item of that burger. So the base item burger has a stack size of 64, and it's going to do the math and determine how much of this can I currently, or how much of this I need to keep stacking after this is done. So it's like if the base, or if the item has a larger stack size than what the base item can actually hold, it keeps recursively calling this function over and over again until it adds all of the necessary amounts until we reach 0. So that's kind of what goes on in here. I thought this was going to be a lot harder, but this actually ended up being not too difficult. It's definitely a mindfuck, that's for sure. Like this is a mindfuck. But yeah, so we have add. So now we have a way to do recursively add items to the inventory until it's done adding it. Is it better to use React.js for WebView? It depends on what you know. If you don't have any core understandings of JavaScript, then I would highly suggest you just learn the basic fundamentals. Oh, 1 second. I'm getting a phone call. Hold on. Fucking Christ. I am muted. Thank you. I'm sitting here fucking talking my brains off and... Alright, so we're doing the subtract here. Thank you for fucking... Alright, so what's happening is I'm doing the subtract function first. Or next, rather. It's similar to add, but there's a few things that kind of go into it that are just slightly different. So yeah, let's do that. God. I should have checked all my stuff. Anyway, alright, so we're doing subtract. We want to do... We don't care about slot count. Doesn't matter. We have a strict check. And we're going to return the remaining amount based on what is found. So the first thing that we need to do is check if this is undefined. We define it, and then we return item.quantity. All right, and then we need to check the currently existing items. So let's take the item reference here, or the items rather. I want to learn framework now. Which one do you recommend, React or Vue? So, oh, I went into a whole spiel about it, and I was muted. So with those two, both of them are strong. I personally use Vue. I have been using Vue for almost a year and a half, maybe 2. I don't remember how long I used it for. Before Vue, I used Preact, which had state management issues that were, it was too, I can't remember what the reason was, but it was too, it wasn't getting all the updates. So I had issues with regular React, or I mean Preact. But between the two of them, I personally really love Vue. I have looked at Svelte as well. But as far as WebView performance goes, I've had no issues with Vue. I know that there are servers that use React and things like that, but personally, I choose not to support Facebook. So, because Facebook is quite the evil company. So, but hey, your choice on what you want to do there. So what we want to do here is if the strict check is set to true, what we want to do is see how much we can remove. So we're going to do base name quantity. We're not going to check if the item exists in the database because it doesn't matter. We're just checking if it exists on the player. Now, to remove the items, so to remove the items, we need to do first, which is the strict check, which is calculate the total amount of items that exist with that base type, and then if it does not equal that, or is not greater than or equal to that, then we just simply return that they don't have enough, which is the quantity that failed to be removed, which is what's happening here. So let's go ahead and determine that. So if we do let item of items, if item.base is not equal to the base name, then we want to continue. If and then we want to actually calculate this total amount. And now we're going to do total amount plus equals item dot quantity. And then if total amount is less than the quantity we want to remove. So let's change this to quantity to remove. So that's super clear on what's actually happening here. So if the total amount is less than the quantity to remove, we return the quantity to remove, because that's all the amount that we did not remove. Return the amount that we did not remove. Strict means it must have this amount to remove it. Okay, perfect. So now we have this. We don't need to do an inventory update or anything because we didn't change anything. So now for the rest of this, we're going to go through and remove until we have none left to remove, right? So let's find the items that apply to this. So what we want to do is work backwards through this array so that we can remove quantity as we're going through it. Let's see here. I really just need to create a few snippets because whenever I do a backwards for loop, I always just forget how to do it. It's just like that information is just always gone. All right, so we have items length, right? And as we're going through the items and going through them backwards, we want to find the items that are the ones that we need to remove from. So if we do, let's grab this here. So we're looking for items I.base. Items I base is not equal to the same base, and we continue. Now what we want to do is if items I dot quantity is greater than okay, we'll do 3 different if statements here actually. So for items I quantity equals the amount to remove, which is quantity to remove. So if it equals this amount, then we simply just remove the item, we're done, and we return 0. So we do items, splice I, 1, return 0, and we do a state update. Just like that. If it is the exact quantity, do a simple removal. All right, now we're going to check if items I dot quantity is less than quantity to remove. We want to take the amount that we can remove and remove it from quantity to remove. So we do quantity to remove minus equals items I dot quantity, right? And then we do a splice like this. And then we do continue. Now for the next one, this means that if this is the item has a greater quantity than what we want to remove. So here we're going to do items I dot quantity minus the quantity to remove. And then we just do return 0. But here we need to do state manager update for this part. Wait, let me double check what's happening here. Quantity to remove. Yeah, that makes sense. And then we just do quantity to remove here at the end. Okay. Yeah, I just had to think about that for a second. All right, so what is happening? Let's talk through the logic of what the fuck is happening in this function. So we pass it a burger, and we have 64 burgers in there, and we want to remove a burger. We make sure that they have enough. So if the total amount of burgers is in the inventory is not enough, then it will just return the quantity that did not get removed. Otherwise, we go into the items, we find that burger with the base name, and if it's the exact amount, we just remove the whole item. If it is not the exact amount and the item quantity is less than the quantity to remove, we do quantity to remove minus what's in this item, and then we remove the item. Otherwise, we go to the next item. Yeah, we go to the next item. And I'm actually trying to think, like, what's happening here. So, like, let's say we removed an item, we're finding the next item. It's not return 0 here. This means that it's greater than, but we still end up with, like, quantity to remove down here, so eventually you just end up, like this. Okay. So that should help with getting that through. And we do the state manager update here at the end because these two functions are still making changes. And we set. Yeah, no, wait. Item has greater quantity than what we want to remove. So then we would just do a break here. And then that would do the state change, or the state save. Removing large quantity, but still need to remove more. Okay, yeah, I think that makes sense. Just another slightly confusing function. So what is this going to be described as? Recursively, it doesn't recurse. Goes through the items and tries to remove as many items as possible. If strict is set to true, it will ensure there is the exact amount of items before removal. Returns the quantity that did not get removed from the inventory. Zero means all items were removed. All valid items were removed. Okay. Okay, cool. And then we probably need to do weight calculation again, which I think we can probably do that here. And we can also, no, we just need to do it minus equals quantity. That's a splice. So we just need to do a weight calculation here. Okay. Seems good to me. And let's add a +1. Boom. And then this should autosave, autosync, I believe. Let me check. I could probably add the sync for the inventory and stuff in here when it gets updated, but actually the reality is I should probably actually just do it here. Shit, I can't remember how to do that actually. That's not gonna be in there at all. Athena, player, sync, inventory, player. All right, so we need to do that after each set here. This. set. Got it there, got it there, got it there, got it there. Okay. All right, there we go. All right, so that's set up with the synchronization, I believe. Okay, so we did sub, we did add. Equipment is going to be a little bit different because there's equipment slots based on like hats and things like that, so that's going to be a little different. The toolbar is a simple, I want to say add or remove. And then it also needs to swap, so that's going to be some different behavior. Hey, how's it going? What else am I missing here in this? I think for now, I'm going to stop here for today because I just wanted to work on this for a little bit, and getting these two big functions out of the way was definitely on my list. I mean, this is actually, these were some harder functions to understand. But yeah, I think I'm just going to stop here for today. But thanks for tuning in, guys. Probably catch you another day.